What's up, future fighters? We are back. We are visualizing the code for the Shadow AI to do the auto detection of strike distances. And this is video number 7 in today's series on that. You can go to the Making a Future Fighter playlist and watch the rest of those. So 134, 134. We're gonna write some values down here. I'll get some spreadsheet going. So my x 1356, and then opponent x, and then distance from opponent. Okay. And that's gonna be it should come out to this. Okay. Let's call this distances. And okay, I'll stop that. And do the same thing here. That's the wrong button. And I'm too close. Let's start that over. About right here. Yeah. Let me do that again. Oh, it's actually perfect because 283 is the value that we used. 283.2. And then my x is 133.8. Now. Of course, the same distance from opponent, 161.21.2, 21.21.2, calculated distance from opponent equals this minus this. And you can see those match. Okay, difference. That's minus that, and that should be 0 if we're doing everything right. Okay, so that is indeed how I am measuring things. And right now, using right now, so my x value is 1338. Now, x value, notice the x value doesn't say this doesn't change, but the sprite offset and the distance sprite edge, all that does change. So when I originally did this, I wasn't taking into I mean you are taking into account the frames before the strike and the strike frame. I mean, I'm doing it visually, through basically just natural linear regression analysis. I know how far, I know what it feels like. I've done that move so many times. I can predict that if I start it here, I'm gonna hit the guy, or if I dash and start it back there, I'm gonna hit the guy. I mean, I know this. That's how you play any video game. You just get those visual spatial relationships down. Now, but we got to teach the AI how to do that. We got to teach AI in mathematics, in mathematical language, because that's the language the AI speaks. We have to teach it how to do that as well. And so what I want to do is I'm exploring this. Let's get to about 283 here. That's about 283. And I'm saying, okay, this doesn't change, but my sprite offset changes. So and I'm kind of we're basing the calculation now based on the edge, the distance to sprite edge, from my x to that, and then from that to the x. Now, the first thing we need to do is we need to get that distance to sprite edge in there, because right now we're just using x offset. And strike sprite. And we're going to need to get sprite width. I think this is a function. Let's see. Yeah. Okay. See, we're adding X offset there. And then this will be edge of, well, I guess this would be distance to edge of sprite. Before we do that, let's not create a memory leak here. Distance to edge of sprite. Because all these variables get thrown out of RAM at the end of the script. And that's going to be your sprite width minus your X offset. And that distance is really what you want to be adding there. And just going to save that real quick. And the reason is because let's just say we're not moving. Let's take horizontal motion out of the equation. And so this frame distance would be 0. It's 0. So you just have the distance to the edge of sprite. That becomes your strike distance. Okay. So let's just say that. So sorry, let's see if I can do this quick. Okay, this is good. Right before he hits. Now, the distance to the edge of the sprite is my X value, which is 151. So the center of the sprite is going to be about right here, which I didn't display. And I've offset it back to about right here. And the reason I know that is because the distance to sprite edge is greater than the distance to this. So it had to go backwards so that 151, well, I guess it didn't have to go backwards because actually it's measuring 151 to here. Yeah, it's backwards because center, if it was, you're offsetting it from the center. So you have to move it backwards to make this distance greater than the actual sprite offset distance. I hope that made sense. Go back, slow the video down, and watch it if it didn't. Anyway, so it's moved back to here. So that is my sprite offset. However, really the only thing that matters, but the X doesn't change. The X value doesn't change. It's just where you're offsetting the sprite. So what I need to do is really I just need I need to what I'm trying to do is I'm trying to take this and I'm trying to marry it up with this value here, which is measured from a standing position. So we know that if I'm here at 280, I'm going to be able to reach him by pushing forward. And okay, so we take that out of the equation. We say, yes, I can reach him here. Okay. And so the X value doesn't change. So what is the distance that we need then? distance to sprite edge. So that distance it would actually give you a little bit extra, because the X is centered. Not in the sprite, of course. It's centered in this sprite. That's for sure. And so we're actually we're kind of doing like a little bit of a different type of equation. So it's obviously so if you just needed that, how far would you need to be? 213. And that's from my fist, so to he has to actually be kind of leaning forward. You see that? I miss him here. So let me. Okay, I can touch him anywhere now. So 205 is really taking our two X values of each opponent. That's where really we need to be. And then so we need to take the distance from our X value to the edge. So it would be X, let's see here. It's going to be well, we're doing it by, this is distance between the two X's. This actually doesn't have to do with the opponent's hand. That is a complicated problem. I might actually have to draw a little bit of this out. So in the meantime, while I work on that, go to docrockgames.com. Let me see. There we go. And check out the alpha version of the game. You could see what features I currently have in the game. You can see the two characters I currently have motion captured in the game. You can see those moves, motion captured characters and features in action, and you can see where you can put in your email address in at the bottom and get notified of release. Then come back to YouTube, because we're going to make more AI. I'll see you there.